Alright, you 11s. So hopefully Wednesday, Thursday, you've had practice with exercise 3I on discriminants. Okay, and hopefully you've mastered or at least understood what you're actually doing. You're trying to find p values, x values, or m values such that your graph has 2, 1, or no solutions. Because without that skill, exercise 3J would only be more complicated and you wouldn't understand it. Okay, so make sure to have 3I down. Now 3J, what we're doing now is we're looking at a straight line intersection of two different graphs. Okay, we're looking at this graph. That's a straight line equation, and this is a quadratic equation. You're looking at when these two intersect. Okay, and obviously when they intersect, you either have two intersections, one intersection, or no intersection. Does that remind you of something? That's what we've been doing in 3I. We've been looking at when discriminant is positive, which means you're going to get two solutions, or 0, or none. Okay? Now technically you've already done that. That's exactly what you've been doing. The only difference is you've been doing this. You've been doing this type of straight line, where this is always y equals 0, which is your x-axis, and you're always asking, is it 2x intercepts, so that's 2, 1, or none? That's what you're doing. So it's exactly the same thing. The only difference is instead of it being y equals 0, now you have, possibly y equals 3x minus 4. Okay, that's the only difference. That's why I said it's very important to understand what these symbols actually mean. You're just saying, when you say 0 equals to x squared minus 4x, for example, you're just saying, when will the straight line y equals 0 be the same as the equation of y equals x squared minus 4x? That's what you're saying. You're just saying you've got two different graphs. You got this graph and you got this graph. You just want to know when they both cross, because when they both cross, they both have the same coordinates. In this case, it will be the y coordinate. That's what you're saying here. You're saying this y coordinate is equivalent to that y coordinate. Okay, so let's do some examples just so that you understand how to do and what I mean. Okay, so let's jump right into it. Let's take this example. Find the points of intersection of the line with equation y equals negative 2x plus 4 and the parabola with equation blah. Okay, well, what you're saying is you've got this equation and you want to know the points of intersection. Very simple and easy. There's no m values, no discriminants at this point. You're just trying to solve for the 2 points of intersection. Okay, you've got a straight line equation and you've got a parabola. Most likely they cross. Okay, I can even show you on GeoGebra as well. Like we can look at this. So x squared. So actually, I'll do a new one. Let's do a new one. Okay, let's have a look. So if I just went to, let's call it f of x equals to x squared. What was it again? X squared. Wait, what's going on? Where is my? Well, I've got too many files. 3J resume slide. And okay, so it was x squared minus 8x plus 12. Okay, so minus 8x, minus 8 or 8 times x plus 12. Is that right? Yeah. Okay, so this is my parabola. That's the parabola for x squared minus 8x plus 12. Okay, and then I've got negative 2x plus 4. So I mean, if I look at it, I'll call it g of x equals negative 2 times x plus 4. There we go. Obviously, you got 2 points of intersection. Okay, and then you got to solve that. So clearly, you do have 2 points of intersection. So if we were to solve it, we should be able to see 1 here and 1 there. So it should be about 2 and possibly 4. Okay, let's test that. So that was a visual cheating. I was sort of using a program to see it. But let's try to solve it mathematically. Okay, so actually I'll do it on OneNote because this computer lags. So let's try a new one. Okay, so we said y equals negative 2x plus 4, and we're saying y equals 2 x squared minus 8x plus 12. Now you see, when they both intersect, when you have a parabola and you have a straight line equation, when they intersect, you see this coordinate of intersection, whatever the x, y coordinate is, they both graphs, the blue and the red, have the same y and same x, because right at that point, if it was, let's say, 3, 3, they both have 3, 3. So that's why you can say, oh, that means this y coordinate and this y coordinate, if they intersect, it's gonna be the same. And that's why you equate them, okay? And it's not, you don't just do it out of nowhere. You actually let them equal to each other, because you know these two y coordinates have to be the same. So if I do that, this y equation, negative 2x plus 4, that y coordinate has to equal to this y coordinate, which is x squared minus 8x plus 12. Okay? So having said that, then let's solve this. So negative 12x, I'm going to move everything across. I'm going to say, all right, I'm going to add, this is minus 4, so I'm going to minus 4 on both sides. Cancels off. 12 minus 4, that gives me x squared minus 8x plus 8. And over here I still have a minus 2x. And then what I can say is, since that's a minus 2x, I can say plus 2x plus 2x. And that conveniently now gives me 0 equals to x squared negative 6x plus 8. And then here, we're just trying to solve. See, when you solve for x, what are you doing? What is this x equal to? This is your x coordinate. That's what you're looking for. You're looking for the x coordinate at where they both intersect. So if I do this now, this is just using null factor law again. Factorize the quadratic. You know, what's this? 4 and 2 will work out. And if it's both negative 4, negative 2. There you go. Using null factor law, that tells me either x minus 2 equals 0. Therefore, x has to equal to 2. Okay. Or you have x minus 4 equal to 0. Therefore, x equals to 4. Which was true, because according to my GeoGebra, that's exactly what I was seeing. You see, it's sort of like it's hitting at 4 and 2. But what we haven't found is the coordinates. I just found the x coordinate. So I need to now find the y coordinate. And the funny thing is, a lot of students get up to this step and then they leave it. You're like, well, you haven't found the coordinates of intersection yet. You know the equation was y equals negative 2x, what was it again, plus 4? Plus 4, yes. Plus 4. Or you had the other y equation, which was x squared minus 8x plus 12. Doesn't matter which one you sub it in, because this tells you what the y coordinate is if you knew what x is. In my case, I'd probably substitute it into this one because it looks easier to sub in. So y will equal to, if it was 2, if x was equal to 2, well, then it's negative 2 times 2 plus 4. Negative 2 times 2 is negative 4 plus 4 is 0, which makes sense because my graph indicated that. Look at that. That's a 2, 0. So it's true. When x is 2, y is 0. That's what I just calculated. Yeah? When x is 2, y is 0. That's what I just worked out. Let's work out when x is 4. When x is 4, so y equals 2, negative 2 times 4 plus 4. Let's work it out. That's negative 8 plus 4, negative 4. So what does that tell me? That just tells me when x is 4, y is negative 4. And those are your 2 points of intersection. So let's look back at my graph. Is that true? And yeah, roughly, look at that. That's negative 4. It goes over to here. And then over there, that's 4 and negative 4. So it looks right. Okay, so I think my solutions are correct. Cool. And that's all. Whoops. Which one was it again? I think it was this one. That's all I was trying to do. It says find the points of intersection, and I did. Okay, I found the points of intersection. And I had 2, 0 and 4, negative 4. Okay. Let's actually move on to that's what exercise question 2. I want you to do that. If you're having algebraic problems, solving is an issue, factorizing, this is a good time to do question 2 of 3J. But this is what I want to move to. This is now combining discriminants. Discriminants with the skill of solving, combine it all together. So 3I, 3J is now being tied together. And obviously on this side, these are the questions I want you to do. 2 hashtag, 4 hashtag, 6 to 9 for the Friday 3J. Okay, this will practice you trying to, especially these questions here, that will practice you to really understand the tie-in, you know, what the whole point of discriminants is for. So, do an example, and you can use this example to do the next few questions, okay? So I'm going to do 5, you're going to do 6 to 9. So let's have a look at this. It says, find the value of C. So what's C? This is C. You see C? We don't know what C is. This is a straight line equation. It's such that it is a tangent. If you didn't know, tangent means a straight line where it just touches the parabola once. Okay, so what they're really saying is find when the discriminant equals 0. That's all they want you to do. Okay, find when the discriminant equals 0 for this parabola. So you've got an x squared minus x minus 12, and you've got a straight line equation where it's called y equals x plus c, and this is x squared minus x minus 12. You just want to make sure this and this equation will only cross once. Instead of twice, instead of none, we want it to cross once. Okay, that's our goal. So, let's do this. I don't know if it starts lagging, I'll go to OneNote. So let's do this one. I will want to first solve it first. So if they had to find the points of intersection first, because in order for you to have one solution or one point of intersection, well, you got to find the equation for the intersection first. So the intersection will occur, you got y equals to x plus c, and you got y equals x squared minus x minus 12. So if the point of intersection, these two values are the same. So by that logic, I can then say, okay, well, x plus c will have to equal to x squared minus x minus 12. Right? Same deal again. Let's bring everything across. I'm going to minus c and a minus c. So I'm going to use a different color so you can see I'm going to minus c and minus c. That cancels out. Okay, and I get my new equation as x equals to x squared minus x minus 12 minus c. Yeah? But then I've also got the x on the left-hand side. And remember, your goal is to get it to 0, because then you can use Null Factor Law. And so from here, whoops, what's going on? I can then say, alright, minus x on both sides, and x minus x is 0. So this now gives me my new equation, which is 0 equals to x squared minus 2x minus 12 minus c. You might be like, man, that c is really confusing. Just c is a number. So that means, look, the coefficient of x, which we already know. This is your b term. That's your b. Oh, whoa, that was terrible. How do I undo that? I don't know how to undo that. I'm just gonna rub this part off. Blue pen. So what we do know is this is your b term, this is your c, and the coefficient of x squared, which is 1, so that's your a. So if we are now to do what we did in 3i, discriminants. So this is your equation. This is currently your equation. That's your equation of the possible solutions you could have. Okay, all the possible. You can either have 1 intercept, 2 intercept, or 3 intercept. So you're saying the straight line can have no intercept, 1 intercept, or 2 intercepts. So you need to find the discriminant. You want to find how many intercepts there are. So discriminant equals to b squared minus 4ac. In this case here, b is negative 2, so negative 2 squared is 4, minus 4 times a, which is 1, so it becomes 4. and times c, which is negative 12 minus c, that's my c. So if you expand this now, that becomes 4 plus 48 plus 4c. So you get 52 plus 4c. That's your discriminant. And this is going back to exercise 3i again. 3i says, depending on what your c values are, this is going to affect your discriminant. Affect the number of solutions you're going to have. So, logically, again, telling you to sketch, this is your discriminant. This is your c axis. So depending on c, you will affect your y-axis where discriminant is positive. See, that's positive discriminant. Right here is discriminant equal to 0, and anything below is discriminant no solution. So if I asked you to sketch this now, this is a straight line equation. Instead of calling it c, it could have been x. It could have been 52 plus 4x. So it's a gradient of 4, y-intercept 52. So I can already say, let's say that's 52. And it's a positive gradient, so the intercept is at negative 52 divided by 4, negative 13. So negative 13. So I've just solved it very quickly in my head. I said 0 equals to 52 plus 4c. Negative 52 equals to 4c. Divide both sides by 4, so negative 13. So that just tells me the c-intercept is negative 13, and this is my graph. So that describes my problem. Whatever c, if you chose greater than negative 13, you get a certain situation. You make c equal to negative 13, you get a situation, and less than 13, you get a situation. So let's have a look. Let's have a look at this problem. So the question says, sketch the parabola with equation negative 2x squared minus 6x plus 2. Where I still don't understand. Oh, it says find the value of c such that you get a tangent. Well, clearly, you get a tangent if discriminant equals to 0. Well, when it's equal to 0, so this is my equation. This is when discriminant equals 0. I already solved it. It's at c equals negative 13, so I've done the answer already, actually. Okay. And in part B, it is the same thing, except this time that's your letter M. So instead of it being C before, like this one up here, it is now M, but you still follow the same thing. You're trying to find when you get a tangent. Okay? And again, same thing. Use the discriminant of the resulting quadratic. Okay? Same deal. No other difference. So please have a go at these questions, okay? Rewatch it if you need to. The real key thing is 3i. You have to understand 3i, because then this step that I'm doing right now would make so much more sense. So really, what's 3j? 3j was just practicing solving this whole section here, equating the two equations. So really, to get that practice, it was question 2 and question 4. That's all you're doing. You're just finding out points of intersection. For each one of these, you're finding the points of intersection. However, this is the section I want you to do. 6 to 9 is because that really ties in the understanding of what discriminant is, how to read inequalities and find out how many solutions you get. Okay, so hopefully that makes sense. I think that should be sufficient. I think I spent a lot of time on 3i, so rewatch that, redo I, and then once you can do I, then J is really easy. It's just basic algebra that you're trying to solve. Okay, I'm gonna leave it there, and call it a night. It's getting a bit late, and it's taking a while to upload. Hopefully you guys can access it over the next 3 days. But good luck, and I will be back on the weekend. And post any questions. Use the discussion forum. Help each other. Help each other. If I don't have the internet at the camp, I can't answer the questions. But on the weekends, I'm able to do that. Okay, so use the discussion forum. Ask each other. Help each other. And I'll put some quizzes out to make sure that you're on track. Okay? Alright. Thank you. That's it. Discard. And somewhere down